So here I want to work from the previous video. We have found the eigenvector to be w0 1 rho m rho m square and so on and so forth. We can just use w not equal to 1 because it's just scaling the eigenvector. So we can write the eigenvector like this. Now if we write down the eigenvalue and eigenvector equation for the circulant matrix C of x, by x we mean that we are using the x vector as the first column of the circulant matrix. Then we can write the eigenvalue and eigenvector equation. We are using the same eigenvector because we know that if two matrices commute, and by commuting we mean this, C times S times C is equal to C times S, then they have the same eigenvectors. So C will have the same eigenvector as S here because it's a property of the circulant matrix and the shift matrices. Then we can write the circulant matrix this way. This is our eigenvector, this one, and lambda m is what we're trying to find out, and this is our eigenvector. So if we take only the first equation, actually what you'll see, you can verify that yourself, that all the equations are actually the same, just multiplied by rho m. So what we can do, we can just only take the first equation and we can write the first equation like this. The lambda m times 1 is here, and this column times this row is just here. We can write x of 1 times rho m n minus 1 like this because I just in one of the previous videos I have told you that the indexing is nothing but it's circularly shifting. So, and also rho m is one of the roots of unity, twice pi over n m. So if I subtract n, it will give me the same value. So I subtract m from here, n from here, so that gives me rho m to the power minus 1 plus all the way to x to the n minus 1, x of n minus 1, which is this, and rho m1, I just subtract n from here, that gives me minus n minus 1. So this is nothing but the DFT of x. So the discrete Fourier transform, the formula we all know, is just the eigenvalue of a circulant matrix, and the DFT, whose DFT we are taking? We are taking the DFT of the first column of that circulant matrix. Or we can also say the first, that will be only the first column. The first column of the circulant matrix is the eigenvalue. So the DFT of the first column of a circulant matrix is the eigenvalue of that circulant matrix. We can use actually the property of this DFT to diagonalize the circulant matrix and look at what actually a circulant matrix does to a vector. What does it mean if we multiply a circulant matrix with a vector?